axial, mixed flow, and centrifugal fans are three different impeller architectures, but there is no universal winner. Start with the required duty point, installation, operating schedule, and constraints. This comparison is a selection framework, not a ranking of unmatched catalog maxima. Classify the fan by the air path through the impeller, not by the casing's silhouette. An inline cylindrical housing can contain axial, mixed flow, or even inline centrifugal geometry. Confirm the exact wheel, guide vanes, inlet, and discharge arrangement before comparing anything. In an axial fan, air travels mainly parallel to the shaft. This architecture can package high flow in a straight path, but pressure capability, efficiency, stable range, and sound vary widely among propeller, tube axial, and vane axial designs. In a mixed flow fan, the impeller gives the air both axial and radial velocity components. Guide vanes may recover swirl and return the discharge toward an inline direction. That geometry can bridge useful duties, but it does not guarantee a universal middle pressure or efficiency. In a centrifugal fan, air enters near the axis and leaves the wheel mainly radially before the casing or diffuser manages the discharge. Blade shape, wheel width, housing, and speed strongly change pressure, power, efficiency, sound, and stable operating range. Set one fair comparison point: the same airflow, the same static or total pressure basis, the same air density, and equivalent speed in control conditions. Keep inlet and outlet test configurations, accessories, fan boundaries, and electrical or shaft power definitions aligned. The application runs where the fan curve meets the system curve. Ducts, filters, coils, dampers, silencers, transitions, terminals, and fouling all add resistance. Poor inlet or discharge geometry can create system effect that erases an apparent catalog advantage. Check the allowed stable region, motor and drive loading, speed limit, temperature correction, and variable speed range. Startup, dirty filters, damper positions, and parallel operation may move the duty point. Never demonstrate induced stall, surge, overspeed, or reachable rotating parts. Fan laws only scale geometrically similar fans under comparable conditions. They cannot convert axial test data into a mixed flow or centrifugal claim. Clearances, blade angles, Reynolds and Mach effects, and approved speed limits remain product-specific. Compare efficiency or fan energy index only at the same duty point and electrical boundary. Annual energy also needs the operating schedule and control strategy. One peak efficiency value cannot describe a building or process that spends most hours at part load. Compare sound power with the same standardized method, duty point, fan boundaries, accessories, and frequency spectrum. Sound pressure in a room is a separate prediction. Smoke, grease, explosive, corrosive, hygienic, hot, or outdoor service requires exact construction and current certificates, not a family label. Release procurement only when the passport is complete. Application and medium, common duty point, system curve, certified exact model curves, stable region, motor loading, controls, sound spectrum, installation drawing, materials, certificates, guards, service access, and identical commercial scope. Then choose the architecture that fits the evidence.